Okay, we are going to complete lesson 3.2C, which is on page 36 in your module. Remember that as you're filling in the pages along with me, you can pause and rewind this video for whatever reason. We're going to go ahead and get started. This is mostly a review, properties that we've already seen in Module 3, but we're looking at them all together. Starting with the commutative property of addition, for the algebraic statement, remember we can say that A plus B is equal to B plus A. And the commutative property of addition simply means that we can change the order for addition. And when we change the order of the terms that we're adding, it does not affect the sum. Some examples, or an example, just to keep things short and sweet, would be 3 plus 5 is equal to 5 plus 3. And if I simplify both sides of the equation, I get 8, proving that it doesn't matter what order the terms are in, I get the same sum. The commutative property of multiplication, of course, is similar. Our algebraic statement this time is A times B is equal to B times A. And of course, we can change the order for multiplication. So changing the order of the factors does not affect the product. And as an example, we can say that 4 times 6 is equal to 6 times 4. And once again, if I simplify both sides of the equation, I have 24 on the left and I have 24 on the right, proving that the order of the factors does not affect the product. Next up are the associative properties. So the associative property of addition says that we can change the grouping of the terms that we are adding and it does not affect the sum. So algebraically, we can say that the quantity A plus B plus C is equal to A plus the quantity B plus C. So notice that the grouping on the left is different than the grouping on the right. And of course the meaning is that we can change the grouping for addition. And we'll give an example using numbers so that we can simplify and prove that the sum does not change. On the left side of the equation, we will group 2 plus 5 and then add 1. And on the right side of our equation, we will change the grouping. So we have 2 plus the quantity 5 plus 1. And if I simplify over here on the left side, I would have 7 plus 1, which is 8. On the right side, I would have 6 plus 2, which is also 8. So once again, proving that the grouping of the terms that we are adding does not affect the sum. The associative property of multiplication is similar, of course. On the left side, we'll say that A times B, in parentheses, so grouped, times C is equal to A times the quantity B times C. And a similar meaning is that we can change the grouping for multiplication. So the way in which the factors are grouped will not affect the product. And as for our example, we will say the quantity 3 times 2 and then times 4 is equal to 3 times the quantity 2 times 4. And if I use order of operations on the left side, I would have 6 times 4, which is 24. On the right side, if I use order of operations, I have 8 times 3, also 24. Thus proving that I can change the grouping of the factors and the product is not affected. Moving on to the distributive property, we can say that A groups of B plus C is equal to A groups of B plus A groups of C. And as for the meaning, we're just going to define it as A groups of B plus C. And our example will make it a little clearer. So we'll have two groups of X plus 1, and we'll show that that would equal two groups of X plus two groups of 1. Remember, for the distributive property, we're multiplying this number out in front by all terms within the parentheses. So I'm multiplying 2 by x, I'm also multiplying 2 by 1, and then I'm going to add those products together. So of course this would simplify to 2x plus 2, not like terms, so we would not be able to simplify any farther. The substitution property, as far as our algebraic statement, we're going to say that A is equal to B, and A may be replaced by B because they are equal. And for example, the quantity 3 plus 5 times y is equal to 8 times y, because 3 plus 5 can be replaced with 8. The quantities are equal. So in our example here, 3 plus 5 would represent A, and 8, the sum of those terms, would represent B. And the last one here on page 36 is our definition of subtraction, which we first learned back in Module 2. And this is the property that allows us to rewrite subtraction expressions as addition of the opposite. And for example, algebraically, A minus B is equal to A plus negative B. And subtraction can be expressed as addition of the opposite. And again, we've been doing this since back in Module 2 when we first started subtracting integers. As an example, I can say that 3x minus 4x is the same as 3x plus negative 4x. So rewriting my expression as addition of the opposite. Okay, we're going to turn to page 37, and we're going to work through some problems where they are simplifying an expression, and we have to make note of the change that has been made and name the property that was used in order to make that change. We're going to skip over the example, and we're going to start down here with problem number 1. So they've given us the expression 3 times the quantity x minus 4 minus 12, and it's right up here in the top of the table. And they're simplifying it one step at a time as we look down the table. And as I said, we have to describe the change that was made in each step and name the property that allowed that change. So in the first row of the table, because this is the expression that was given to us, we're going to note that there is no change, so nothing has been done with it yet. And that's because it was the given expression in the problem. But if I compare the first line to the second line, I notice that what changed was the subtraction. Instead of minus 4, it's plus negative 4, and instead of minus 12, plus negative 12. So I'm going to note that they changed subtraction to addition of the opposite. So trying to keep our explanations brief. And remember that it's the definition of subtraction that allows us to rewrite a subtraction expression as an addition expression. Now, comparing my second line to the third line, I notice that the brackets, the grouping symbols, have disappeared. And I notice that the 3 has been multiplied by x to give us 3x, and the 3 has been multiplied by -4 to give us -12. So they have simply distributed the 3 out in front of the brackets, the grouping symbols. So distributed, which is the distributive property, of course. If I compare the next two, I see that the -12 and the -12 have been grouped in brackets. So those are both constants and can be combined. So for my explanation, I'm going to say that they grouped the like terms. And remember, grouping terms together is the associative property. There are 2 associative properties, so we have to say which one this is specifically. It's the associative property of addition because they've grouped the terms that they're going to add together. In the next line, I notice that they've actually combined the 2 -12s. -12 and -12 is -24. So combined like terms to explain the change that was made from one step to the next. And of course, that's just the substitution property, replacing one value for another because they're equivalent. And they actually did one more thing. Notice that instead of plus a -24, they've gone back to subtraction. And we typically go from subtraction to addition of the opposite, but going from addition of a -24 to subtracting 24 is also the definition of subtraction. So I'm going to note here that they changed addition to subtraction, and it's the definition of subtraction that allows us to go back and forth between the 2 operations. And so we've used that property 2 times in this expression. Okay, on the next page we have 2 more of these. And I'm going to actually stop this video and start a new one because each video only allows me to record for 15 minutes. And I'm going to need a few more minutes than what I have left for problems 2 and 3. So you're going to end this video and click on the second one so that we can fill in at page 38 together, and then you'll be finished. So I'll be right back. Hang on.